Hello and welcome everyone. So for this video, what we want to do is, first of all, I'd like to start with having to understand the difference between a compiled and a scripted program. So compiled learners, there are two kinds of programs basically. Programs could be of two types of programs, and then there are scripting or interpreted pre-read programs, right? So the difference between compiled and interpreted programs lies in how the underlying machine is going to execute the entire program. Let's say this is our source code. This is a file that contains all the source code to our program, right? And what the compiled program is going to do, it's going to have an intermediate step of compiling the program, that is building the program. That's what we call it as building the program. The reason why we call it as building the program will be apparent when we look at how interpreted programs are being executed on a machine. So basically, you'll have some compiler like a GCC or LLVM client compiler. You'll give the program source code to this compiler, and it's going to generate a machine code that is specific to your machine architecture. Let's say you're running on an x86 Intel or an AMD machine. That's going to generate a different program for that kind of architecture, right? x86 or x64, it's all the same. Or it could generate the program for, let's say, an ARM machine. And these are the most popular consumer architectures that are out there in the market. So this is how the flow is going to be. You're going to have a source code and you're going to give it to a compiler. It's going to spit an executable. So this executable will be directly run on a machine. So your CPU, the hardware underlying the machine is going to fetch the instructions one by one from this executable, and it's going to execute them. And again, there's a whole lot of theory on how this execution goes. In fact, computer architecture entirely dives deep into how all of this steps are performed. There are many optimizations along the way which happens. The compiler is also responsible for that. Some of them are done locally on your CPU, but it's largely a part of the distinction lies in between, that you're going to build the entire program and it's going to be executed. It's going to be executed by the CPU. And the way scripting programs are going to work is, let's say you're going to have this entire program. So the underlying interpreter or the interpreter or the virtual machine, it's also called as a virtual machine, or you can call it as an interpreter. It's going to take a small chunk of your program. It's going to take a small chunk of your program, and then it's going to generate some code for it, some machine code for it, which is very specific to, let's say, your x64, and then there's going to be some different code that is generated for ARM architectures, and this piece of code is going to be run on the underlying machine, the underlying hardware. So this is what is going to be run, and it's going to keep doing that for small chunks of your program, and it's going to keep doing that until you have exhausted all of your program instructions. And that is how interpreter is going to execute the entirety of the program. It's not going to execute it all at once. The way compiled programs are being executed, it's going to execute them one chunk at a time, one window at a time, right? And there are pros and cons to this. So we're not very much concerned about these pros and cons as of now. But later on, yeah, they may be useful for some of you who need to understand the phenomena in much depth. So compiled programs, because they are being built all at once, they are usually faster to run. So on the underlying machine, let's say the compiled program is going to take 100 units of time to run. The same scripted program may take 500 units of time to run. This unit could be anything. And the reason for that is because you are going to break the program into chunks and then generate the code for that specific program, and then you are going to keep doing that until you've exhausted all of the chunks of your program. And this was done specifically. The reason why the early engineers and computer scientists did this distinction is because the machines which in the 1960s and 70s, they had very limited main memory, or the random access memory, or RAM, what we say. They had a very limited RAM, which is why they had the one way of executing the entire program is to break it up and then run it chunk by chunk, and that's how you could achieve a scripted program being run in its entirety. But as the time passed in the 80s and 90s and in the later decades, machines had quite a big memory, and then there were things like virtual memory. Let's not concern ourselves with that, but this is just for a better insight on how this is. Once we had larger memories, we were able to fit the entirety of the program into the memory. So that is why this is where the notion of compiled and interpreted comes in. Okay, so the reason I told you this is because the language that we're currently learning is Python. Python is an interpreted or a scripted language. There are other examples like, if I'm not wrong, JavaScript is a language. I think there's something called as Perl is also a interpreted language, and something like a compiled language is something like a C or C++. Even Java to some extent is compiled, but it's not entirely a compiled language. It's a mix of two. Anyway, so that's about the compiled and the scripting language differences. So let's start. Let's move with the data types in Python. So data types are really important, as we saw in the previous iteration of our series. We saw that data was either numbers or strings or characters, and we saw that the numbers were further divided into integers and the decimal numbers, which are all these floating points or doubles. That's what we call them. And then again, there are strings. Strings are, as I told you, just a bunch of characters. It's a collection of characters, right? And a character is again the simplest unit of data representation in the machine. And the way characters are internally represented is by numbers again. So you have some convention called as a ASCII convention, which is American Standard Code for Information Interchange, which defines the encoding from a character to the underlying number. Because at the end of the day, in a machine, you are going to represent everything in zeros and ones, and we all so far know how to represent any given number in our binary format. Even if we don't, let's just quickly gloss over it. I gave an example in the last lecture, I believe, but let's just quickly understand how to represent a number like, let's say, 8 in the binary. So what is the binary representation? So this is this is in the decimal representation. Let's extract what is the binary representation of 8. So what we'll do is we'll simply keep on dividing 8 by 2, and we'll write the remainder in the other column. So let's divide it by 2. We have, so on dividing it by 2, we left the quotient with 0, and our remainder is going to be the quotient will be 4 and the remainder is going to be 0. Keep repeatedly dividing it until the given number is less than our base that we want to convert it to. That is the binary one. That is 2. So we repeatedly divide it until our quotient is less than the base or the number that we want to represent it. So 4 is again greater than 2. We'll keep dividing it. The quotient is which is 2, that binary will write the representation from below to the top. So that will be like 1 0 0. Yeah, that's right. So 0, right? 1 0 0. So that's going to be the representation for 8. And if you just want to confirm it quickly, all you need to do is multiply every digit, that is every bit, and we have to index all these positions. So we're going to index it starting at 0, 2 raised to 0. So this 0 will go over here and you keep adding that. So this 0 times 2 raised to 1 plus this 0 times 2 raised to 2, because 2 is the index, and then this 1 times 2 raised to 3. So 1 times 2 raised to 3 is going to be 8, and everything else is going to be 0. Hence we got our original number 8. So that's how we are going to convert between binary and decimal representations. There are other kinds of representations, but we don't need to concern ourselves with them just yet. Right. So we have these data types. So we have these data types with us. So as we said, there are a number of data types that we have with us in Python. So something like 20 would be an integer, and let's say something like 1.73 would be a float or a double, depending on the number of bits are assigned, but it's going to be mostly a float. I don't think there should be a double anyways. And something like, let's say, hello should be a string. String is also represented by str in Python. So let's just quickly try to see what is the data types of a given data that we want to give it as input. Let's say, okay, let's not deal with inputs right now, but let's just say that there is a function called type, and you could give in any entity. Let's say I'm going to give 20. Let's say it's fine, 29, and it's going to print what is the type of the given entity. So this is going to print as usual from the last program, but at the end it's going to print an integer. That's right. It says class int. It says class. Well, let's not concern ourselves with the keyword class for now. We'll look at it later on. It is what comes into the object-oriented programming framework in Python. But the important thing is this given object is an integer. We could have said something like 29.4. It's going to give us, let's say, it's going to say it's a float, right? Let's also investigate what is the type of something string. Something like, let's say, root. So it's going to say str, that is string. So let's do one more. Let's say what is the type of let's say at the rate. It's going to say, oh, it's again a string. So yeah, this is what. So a notion of character is not the same in C++, C and Python. So a character in Python is just a string with length 1. It is just a string with length 1. So there is no such thing as a character. It's only a string with length 1. But there is a distinction between what a character is and what a string is in let's say Java, C or C++, these compiled languages. Right. So those are the important, or at least the most used data types in Python. And then there are some user-defined data types. There are also complex number data types, but we're not going to concern ourselves with that just yet. So we are going to go on a use when we are going to use the things. We'll look at them specifically then. Right. So let's move on to let's say how to make decisions in Python. So that's an important bit that we need to understand. So before that, let's understand the operators in Python. So I'm going to create this.py. I'm going to create a new Python file, and we're going to understand the operators in Python. Before that, let's take a look at operators on our whiteboard. So an operator is going to it's something like the arithmetic and the logical operations that we're going to perform on the data that the user gives us, or the data that is there available with the program. Right. So let's say the simplest of operations are going to be something like addition, multiplication. So, this is the representation for multiplication, and the okay. So there is different kinds of division. So this is division where it's going to give us okay. So this is a division which is going to give us the floating point representation, and then there is something called as integer division. So this is only going to give us the integer portion of the division, or so to speak, just the quotient. But this is going to give us the entire decimal representation. So there is also something called as a modular operation. So this is going to give us the it's going to give us the remainder. Let's say I'm going to divide. We'll see this with an example. Let's say we're going to divide let's say 7 by 2. This is the mathematical representation. Let's say 7 by 2. So that in the mathematical world it's going to be 3.5. But if you are going to use the operation 7, the first operation, this one, if you are going to use that, it is going to give us 3.5 in Python. So keep in mind, this is very specific to Python. This may vary depending on the language that we are using. And let's say if we use something like this, it's only going to give us 3. As I said, it's going to give you the quotient. And if you are going to use something like a modulo operation, it's going to give us 1, which is the remainder that we are left with when divided by 2. So these are the kind of division operators that we have with us, and the rest of them are pretty standard, the addition, subtraction and multiplications. Now there are different kind of operations which are also called as logical and relational operators. Okay, before that, let's look at what are the comparison operators that we have with us. So let's say 7 greater than equals to 2. So this is 2. So this will turn out to be 2 because 7 is greater than or equals to 5, greater than or equals to 5. This is also true. So the output of such an operation is either going to be true or false. It's going to be either true or false. We can also represent this by either a 1 or a 0. 1 or a 0. 1 meaning that it's true, 0 meaning that it's false. Right. Let's say something like -1 greater than 5. This is going to give us false, which will mean that this has interpreted to be a 0. So false is equivalent to 0, and so 0 is equivalent to false in Python or most programming language, and a non-zero value is equivalent to true. So these are the equivalence relations that programming languages generally tend to follow. This is usually the standard. If any value turns out to be 0, it's considered as false. if we are going to think from a the arithmetic, let's call it the Boolean algebraic framework, and if it turns up to be non-zero, then we consider it to be true, right? So these are our operators. So this is going to be greater than or equals to, this is going to be greater than, this is going to be less than, and this is going to be less than equals to. And if you want to compare exact equality, that is going to be a double equals to, right? But now keep in mind, double equals to is equality comparator, right? But a single equals to is an assignment. It's an assignment. It means that we are going to assign a value of, let's say, assign a value of 9 into x. That is, we are going to store the value of 9 into variable x. That is what this means. But if we say that x equals to 9, it means that we are checking if the value of x, which is already there with us, if it's equals to 9, then this expression is true. This is what we mean by that. So bear in mind the differences between the double equals to and the single equals to. The double equals to is for mathematical comparisons or object comparisons in general, but whereas the single equals to is for the assignment. That is, you are assigning value to your existing variables, or you are creating new variables in case of Python. That's right. So these are the operators that are available, arithmetic operators that are available with us. And then there are some operators like AND, OR. I think there's also an XOR, right? And there's a NOT. So these are operators which are what we call as logical operators. So let's consider well, what should we consider? Let's just say a simple example where, now this is I'm writing it in mathematical terms, where x is 9 and y is let's say y is 12. If we say that x equals to 9 and y equals to 12, this is going to be true, because we've assigned 9 to x and 12 to y, and we are checking if this is indeed correct. That is, we are checking that if x is 9 and y is indeed 12, and since both of them are true, so this turns out to be true and this turns out to be true, which is why the whole thing turns out to be true, because we have used the relational operator AND, or the logical operator AND. This is a logical operator, not a relational operator. So because both of the results are turning out to be true, which is why this entire statement turns out to be true. Right. Let's continue with this example. Let's run with this example. X is 9 and y is been assigned 12. Let's say that either x is 9 or y is greater than, let's say, 100, right? So now we're going to investigate each of these statements on their own. We'll first check, is x 9, right? So x is 9, which means that's true. And what is y? Y is 12. So 12 is not greater than 100, but and so the statement is false. Because we are using the operator OR here, the logical operation of true or false is turning out to be true. It's going to turn out to be true if you find at least one true statement here. That's right. And XOR is going to be true only when opposites are true. Let's say when both the things are okay. Let's try to understand XOR by binary representation. So this is a binary representation of 12, and this is, I'll write a binary representation of 30. I'll try to take an XOR of these things. So an XOR of 0 and 1 is going to be 1, because both the bits are not the same. When both the bits are the same, it's going to be 0. So it's going to be 0 in this case, it's going to be 0 in this case, it's going to be 0 in this case. So XOR gives us either or. So it's going to give us either this is going to be true or that is going to be true, but both of them cannot be true or false, right? Both of them cannot be the same value. So when both of them are the same value, it's going to be 0. If both of them are going to be a different value, then it's going to be 1. Let's take another example. Let's say this is 7 and let's say this is what is this? This is 2. This is 7 binary representation of 7. This is binary representation of 2. Here both the values are going to be different, which is why this is going to be 1. Again, both the values are going to be sorry. This is not 7. This is 5. Right. So that's a pretty trivial mistake. Yeah. Anyway, moving on. So this is because both the values are opposite, which is why this turns out to be 1. Again, both the values are not the same, turns out to be 1. Both the values are not the same, turns out to be 1. And this turns out to be 7. Right. So there's a really neat property that we can see here. Under certain cases, x XOR y can be equals to x plus y. This is true only when x and y are 0, bitwise 0. So this is going to be a bitwise AND. So this is the symbol that's used for bitwise AND. What I mean by that is, it could be. You could also use logical AND here actually, because let's say this is the case. This is the case because the logical AND is going to be 0 here, it's going to be 0 here, and it's going to be 0 here. So the whole thing turns out to be 0. So, but ideally you'd like to use a bitwise AND. Bitwise AND would mean that you're trying to use the AND logical AND operation on every bit by bit, right? So this turns out to be 0. So when this turns out to be 0, only when x bitwise AND y is 0, then you could say that x XOR y is going to be x plus y. As we see, x XOR y turned out 5, XOR 2 turned out to be 7, only when the logical AND or bitwise AND turns out to be 0. That's a really neat property. That is, so this is helpful when we're trying to solve algorithmic problems in Python. Right. Apologies for the interruption. So, that's what this is. We've looked at the arithmetic and logical operators, and let's just see these operators in action. I'll try to increase the font. Yeah, this should make it pretty visible. Now let's say x we will assign to 9. This is a variable that we declared, and we're using another variable as 10. And let's say we're trying to check if x is greater than y. That is the simple check that we want to do. So for that, what we use a construct called if-else. That is it tells us whether certain operation, let's say if x is greater than y, then I want to do certain operation. If that is not the case, then I'll do some other operation. Let's say, and this is how you write it. You write if, and I usually use the braces in Python as well, but it's not mandatory. You could do it without braces, but I find it much easier to read when I write these circular braces. Let's say if this is what we want to check, if x is greater than y, and there is one other piece of syntactic sugar that is used. This is to open the scope. We use the scope operator, that is this colon. We use a scope operator whenever we want to introduce a new scope in Python, because Python is an indented language. We don't have the concept of these braces. So these curly braces are there in C, C++, and Java like languages. But for Python, for defining a scope, we use this colon, right? And this is how we do something. Let's say we'll increment x by 1, x equals to x plus 1. Or if that is not the case, then again I'm trying to open a scope. We'll use the keyword else. We'll use the scope operator, scope opening operator colon, and we'll give the indent. We'll give some indent level, and then we'll write whatever is the operation that we want to perform. X, y equals to y plus 1. And finally we'll try to print x and y. Let's say y equals to, and we'll give a comma and write y. We'll also write a prompt for the user. X equals to, let's not forget a comma over here, because print statement can accept multiple arguments separated by commas, right? Even if you try to forget one of these commas, then it's going to complain. The interpreter is going to complain. And let's just see for a moment what it says. It's going to give us a syntax error. This is what it says: syntax error, invalid syntax. That is, you have probably forgotten a comma over here. That is what it is going to say. Right. Now this is a syntactically correct program, but there's let's also see the side effects of if you try to forget one of these colon operators, because then it won't know, the Python interpreter won't know that you started a new scope and where you need to keep a track of the indentation, the Python interpreter. So let's try to run it. It's again going to complain about the syntax error. It's going to say invalid syntax, and it also points out where the syntax error has occurred. If you can see, there's the upward pointing arrow. There is after the closing brace, that it signifies that we need to introduce a colon over there. We try to run it again. Right. So now you can see that x equals to 9 and y equals to 11. So let's try to understand how this happened. We've defined two variables, x is 9 and y equals to 10. Then we've seen the operator if else. So these are keywords in Python, if and else. Then we've studied the operator greater than, although we haven't given less than or equals to, but that is understood implicitly, right? Because if x is greater than y, then this is the piece of code it's going to execute. Otherwise, if x is less than or equals to y, then this is the piece of code that it is going to execute. Let's see what x is. X is 9, and we are comparing it to y. We are saying that 9 is greater than 10. Of course, it's going to return false. Now, once this statement, it is going to return false. In that case, if the statements inside if is not going to be executed if this returns false. These statements are only going to be executed once this returns true. Now, since this did not return true, that is 9 is greater than 10 is false, these statements are not going to be executed. Although there is just one statement, you could also have there could be multiple statements here. Something like x equals to x plus 10. There could be a number of statements here. But the point is, if this condition turns out to be false, then these statements are not going to be executed. The if block is not going to be executed. Whereas in this case, x is less than or equals to y, which is this. So these statements are going to be executed. So what is going to happen is, the execution is going to happen from left to right. It's going to execute the statement first, and then it is going to assign this value to y. So it will pick the value of y which it already stored, which it is 10. It's going to do an addition operation 11, and it's going to store that 11 back into y, and that is how we see x equals to 9 and y equals to 11. So we'll just understand this entire piece of code on our notebook over here. Okay, let me try to. Right. So we want to see the execution semantics of this program. Let's expand this. Okay, now this is interesting. So what we've done is we've defined two variables. Okay, let me expand this. We've defined two variables, x equals to 9 and y equals to 10. There are a bit of new concepts that are getting introduced here. So you might want to be a bit more attentive to the newer keywords that are introduced here. So what is happening underneath is you're allocating one memory location, that is x for 9, and then there is another memory location y, and you're initializing that with the value 10. Now what this keyword is going to do if, so first we are going to check if x is greater than y. That is, we are going to substitute x over here and y over here, and we are going to see that if x is greater than y. So 9 is greater than 10, so that turns out to be false. Now as I said, if this turns out to be false, what is going to happen is, this is the if block that we have started, and x equals to x plus 1. So sorry, this is going to be x equals to x plus 1, right? So now since this has turned out to be false, this statement or this if block, it will not be executed. It will not be executed, right? So it's going to skip over to another block, that is else block. So this is the start of the else block, and remember that you also have to use these colons, and these are just part of syntax. These are just part of the rules of Python that we need to follow. Otherwise it's going to complain that there is a syntax error. Anyways, so now that we've established that 9 is not greater than 10, in that case this if block it's not going to execute, and it's going to skip over to this else block, and it's going to say y equals to y plus 1. Now the way y equals to y plus 1 itself is going to be executed is pretty interesting for the beginners. So what is going to happen is, you're going to take the initial value of y, whatever is the current value of y, you're going to extract that value, and you're going to substitute it here, y equals to y plus 1. Y plus 1, 10 plus 1 is going to be 11, and 11 is going to be assigned back to y, right? So this is how it's going to happen, equals to y, right? So there's going to be an addition operation, and then there's going to be an assignment operation followed by that. But Python is going to take care of us internally. We don't have to write two different instructions to add and then put that result back into y. Although you could do it, but it's much more efficient to just do it in place. You could have done something like, let's say, you could have said t equals to y, and then y equals to t plus 1. This was possible. This is entirely legal, and it's possible you could do this. What would happen in this case is, this 10 is going to be assigned to t, then there is going to be another memory location t that is going to be created temporarily inside of this. Okay, so this is important. This, if you were to write this t equals to y and y equals to t plus 1, this memory location t is going to be created only for the else block. Once you exit the else block, this memory will be deleted, right? Because the memory is always used in the block that is defined in, and the blocks that are nested within the current block. Although that's a topic for another day. So this is how it would work. So you'd assign y to t, and then t would again read from, although it's going to be the same thing again, it's going to be t plus 1, 11, and then this 11 is going to be assigned back to y, right? So this is how you might want to do it, but this is a poor way of doing it, and it's not an optimized way of doing it, so this is not recommended. Reason is because you're creating a memory location inside the block, and you want to, because memory is a limited resource, and then you want to conserve it. Also, there's an advantage of just writing one instruction. So writing the fewer instructions that you write, the better the performance of your program is going to be. That is not necessarily always true, but yes, in the general case, you could say something like that. But keep in mind that's not always true. So this is how it would work. So at the end of the if else statement, what we are left with is x is going to be 9 and y is going to be 11. You try to print it. Now once you are going to print it, it's going to read x from the memory location of x, and it's going to be 9, and then you're going to read y from the memory location of y, which is going to be 11, right? So this is how we get the result of of this program. And you could try to play around with this the decision making framework in Python, which is if else statement. There's also another statement. If you want multiple decision making scenarios, then you might want to use what's called as an elif statement, which means either you're going to be executing if, or you're going to be executing the other second block, that is elif block. If both of them turn out to be false, then you're going to execute else. Let's say you might want to use something like if x is greater than y, then you want to do something. If x is less than y, then you want to do something else. Let's say x is less than y, then you want to say x equals to y, right? You want to assign the value of y to x. That is the case, and the only case that remains is x equals to y. That is, both x and y are equal. So this will be handled by else case. So let's just understand this program as well. Since we're going through a running example, let's understand the whole thing at once. Right. So let's say this is our program. Again, we're quite familiar with this. We have a memory location x is 9, and then we have another memory location y is 10, and we write if x is greater than y, then this is the start of a if block. But then we see that x is greater than y, it turns out to be false, so the if block is not going to be executed. Right after we decided that this is not going to be executed, it's going to fall back on the next block, that is the elif block. Now this time it's the elif block and not the else block. Now the elif block says if x is less than y, which means you're going to have to check 3 different checks here, not just if it's greater than y or it's less than equals to y, but you have to do you're in a situation where you need to use three of these comparison operations separately, but you don't need to write the exact equality because it's implicitly understood. Since you've used x is greater than y and then you're using x is less than y, then it's implicitly understood that the else is always going to be if both of them are exactly equal. So now we're going to check this statement over here, if x is less than y, right? So we'll again substitute the current values of x and y, and we'll see if x is indeed less than y, which it is. This is why this statement is going to turn out to be true, and this elif block is going to be executed. Now this block is going to be executed. It's going to say x is equals to y, which means whatever is the value of y, you're going to assign it back to x. So, sorry, this is supposed to be x equals to y, and the value of y is x, it's 10, and you're going to assign the value of 10 to x. So what it is going to do is it is also going to fill x with 10, and it is going to exit out of the if else ladder. And in this case you're not going to execute the else statement because you've already executed the elif statement. So whenever you say if elif, and there could be multiple elifs, you're only ever going to execute only one of them, unless and until there is something. The first elif is going to modify some data, and then a later elif, it also turns out to be true. So for example, something like Okay, so this is the exact same example what's going to happen here. Uh, all right, but no, yeah, not in this case unless you were to write an elif equals to y. So yeah, if we are going to encounter such an example, I'll definitely go through that example as well. But those examples are quite rare. But we should always be careful how we are manipulating the data, and if that is how we intend to we intend our program to be executed. So in this case, I believe this is pretty simple to understand. But there's a semicolon that we were missing here. Now this program should work just fine, and it should print x is 10 and y should also be 10. Let's just try to execute it, and this is what it says: x is 10 and y is 10. That's right. Great. So yeah, so these were the operators, the comparator operators. We could also have done something like excluded else altogether and used x is less than equals to y. If x is less than equals to y, this is a very explicit form of saying writing else. Instead of writing else, you could have done this, and it's going to be the same. I think it's going to give us the same answer as the previous one, that is x equals to 10 and y equals to 10. Let's try to modify our data. Let's try to say 99. Now in this case, what is going to happen is, since 99 is greater than 10, we are going to increment x by 1. That is, x is going to be 100 now, and y is going to stay the same. So let's try to print it, and that's what it gives us. X is 100 and y is 10. The reason that happened is because x is 99, y is 10, and 99 is greater than 10. That turns out to be true. Now once that turns out to be true, it's going to execute this statement. So the statement says that whatever is the value of the existing value of x, add 1 to it and assign it back to x. So 99 plus 1 turns out to be 100, and you're going to assign that you're going to update the memory location of x with the value 100, and then you're going to exit out of this if else statement ladder, and you're going to print whatever is the state of x and y variables. That is 10, 100 and 10. Right. Sorry. I mean to say x is 100 and y is 10. Not that x is 110. Right. So yeah, I guess this is pretty much it for the relational operators. Let's also try to go over the logical operators. Let's say if x is greater than y, and let's say x is also greater than 10. So we want to check two conditions at once. We want to make sure that x is greater than y, and we also want to make sure that x is again greater than 10. In this case, that is true because x is indeed greater than y, which is 99 greater than 10, and 99 is also greater than 10. Right. I mean, instead of 10, let's just say x is greater than, let's say, I don't know, 5. Yeah. So x is greater than y, that is true because 99 is greater than 10, and x is also greater than 5. In this case, it's going to give us the same result as the previous one. It's going to be 110. The reason for that is obvious, I guess, by now, because this entire if statement turned out to be true, and this if block is executed. Once the block is executed, we have 110 in the respective places, in the respective memory locations of x and y. Right. You could have also used something like if x is greater than y or x is less than 5, and I'll say something like -1. Now x is greater than y is going to fail because -1 is less than 10, so this condition is going to fail. But this x is less than 5 condition is going to be true because it's the OR logical operation. So if any one of them turns out to be true, the whole thing turns out to be true, and if the whole if turns out to be true, then we are going to execute whatever lies in the if block. So it's again going to give us the same result. That is, okay, now what does it say? Right. No, it won't give us the same result because our data is changed. We say x is minus 1. So x is greater than y is going to fail, and x less than 5, that is minus 1 less than 5, is going to be true. This is why the whole thing is going to be true. And what we are going to do is pick the existing value of 1, which is minus 1, add 1 to it, which is going to be 0, and assign 0 back to x. And that is how x turns out to be 0 here. And you could probably play with this and get more familiarized, help yourself to get more familiarized with the operators in Python, and it allows us to do pretty interesting things. Even though that we haven't learned a lot about Python just yet, it gives us a lot of power in Python for us to be able to do multiple things, right? So yeah, I guess that's pretty much it for the operators. So you could try to use the other operators by yourself, and if there's any doubts that you have, please let me know in the comments. I'll be happy to answer any questions that you might have there. Right. So that's pretty much about the relational and arithmetic, relational, logical operators, and if-else ladders. Now the next thing that what we want to do is functions, and we'll probably do it in the next video. So until then, I'll take leave. Thank you everyone. I'll see you in the next video.